Right, the open shortest path first. What we have seen thus far is it's a protocol widely used both in service provider as well as enterprises. Even we can see this in a data center, which means it's a popular routing protocol, popular IGP protocol within the organization, within the data center, within the service provider network. They always prefer this protocol. The reason is the design. This is the design. You see, two-tier hierarchy. There's a backbone area, and there are many non-backbone area, which is also called as regular areas. So you got regular areas, area 1, area 2, area 3. You can have many areas like this. To connect between the areas, we have area 0. So area 0 is the transit area. Transit area, backbone area, area 0. All three are same. Number 0, area 0 is dedicated only for this backbone area. You cannot use area 5 as a backbone. OSPF is designed like this. 0 alone can be a backbone. 0 alone can be a transit. Only to area 0, the other areas will give routes. Area 0 will not give route, area 1 will not give route to area 2. That's what we saw in the previous class. I drew a line like this. I said, let's say you have area 1 extended up to here. This is area 1, right? This is area 1. This is also area 1. So they form neighbor. So all the routes of area 1 will be available in G. And G also got all the routes of area 2. But G will not propagate area 1 routes to D. It won't propagate. G will have area 1 route and area 2 route, but G cannot propagate area 1 route as well as area 2 route to area 1. So what I'm trying to say is G will not tell F about area 2 network. G will not tell D router about area 1 network. Why? Only to area 0, regular areas can give route. Because there is no area 0 in this router, route coming from area 1 cannot be given to anyone because there is no area 0. Routes coming from area 2 can be given to area 2 interface, but not to area 1 interface. This interface is area 1 interface. Route coming from area 2 will never go on other area except area 0. That's the design of OSPF. So you see, you are forced to have area 0. If no area 0, no possibility of distributing route from one area to another area. And this is also good. Why? So you have a very precise, proper approach of distributing route. You have a very clear approach here. What? You do summarization You summarize and send to area 0. And area 0 will have summary of all other area. And area 0 take responsibility of distributing the routes of one area to all other areas. And if you want to write some filtering policy, you can do everything on this area 0 router. Also on the border router. So nicely designed so that you can have a very proper approach. Now, OSPF adjacency. Adjacency is nothing but forming neighbor and distributing the link state informations and getting synchronized with the neighboring router. Adjacency is not simply forming neighbor. It's more than that. Forming neighbor as well as getting synchronized in database. You remember we learned within an area, the LSDB need to be identical. Within an area, the LSDB is always same, identical. That identical, how it is appear, how it happens, synchronization. They share the info. They share LSUs, LSA, LSU, link state advertisement, link state updates. I told you collection of LSA is LSU. See now, the updates, the link state updates that are shared between the routers without missing anything, fully synchronized, complete identical databases developed. That is what we call as adjacency. So before forming adjacency, first they have to become a neighbor. To identify, to discover a neighbor, the hello packet which is sent to 224.0.0.5 224.0.0.5 is used. So this multicast address is used while sending hello packet. Every router on every port where OSPF is running, they send a hello packet every 10 seconds. Every 10 seconds, the hello packets are sent. And it is sent to this address, 224.0.0.5. This hello packets will not have link state advertisement or link state update. That is separate packet. This hello packet is just hello, which has got the router ID, area ID from where the packet is coming, neighbor list, prefix subnet length, timer. Timer is important. OSPF sends hello every 10 seconds. If a neighbor is not sending hello for 40 seconds, the neighbor is considered dead. This dead timer should match. Always this 4 timer follow is dead timer. 4 timer follow. If this don't match, they don't form neighbor. The hellos won't be accepted in first place. They receive, they check this, and then they drop it if the timer is not matching with the local time. Local timer is 40 seconds, and the incoming timer is, let's say, 30 seconds. They don't accept the packet. Right in the beginning itself, they discard. There is no chance of forming adjacency. So some parameters, certain parameters need to match to form neighbor. The routers declare neighbors to be up after checking certain parameters. So it checks some options in the hello packet, certain parameters. After that only a neighboring router is declared as a neighbor. Forming neighbor or forming adjacency in point-to-point is different. In LAN, it is different. Point-to-point meaning what? You got a serial wire, a WAN cable, we call it as WAN. We draw like this, a zigzag line. That's WAN cable, WAN link. And when you connect two routers and run OSPF, this is considered as point-to-point OSPF network type. What network type? Point-to-point. You no need to configure this. Automatically, the type will be point-to-point. When you connect a serial wire, it is HDLC, or if it is a non-Cisco router, PPP will be the encapsulation protocol. When you connect an Ethernet wire, see, this is how we draw Ethernet wire, just one straight line. When you connect Ethernet wire, it is not point-to-point because Ethernet is the standard. When Ethernet is a standard, it is considered as a LAN link. When any of this is a standard, then it is considered as a WAN link. When you run OSPF on a WAN link, both neighbor form full adjacency. Full adjacency means what? They are fully synchronized. After forming neighbor, they share everything. Whereas in a LAN link, meaning when you run Ethernet, there will be one DR elected, then the second router BDR, and the third router, fourth router, fifth router, they all will be DR others. Say for example, I have only two routers, router 1 and router 2. In that case, one will be a DR, another will be BDR. Based on the router ID, if priority is not set. If priority is set, then based on the highest priority. DR is elected. We'll talk about that later. Now, what I'm trying to say is, when you have only two routers, they have full adjacency like point to point. Here also full, here also full. Can you connect third router in the serial wire? Not possible. That is why it is called as point to point. You cannot connect third device. But here I can connect. What I can do, I can place a switch and I can connect third router, fourth router, fifth router. I can connect many routers. That is why it is LAN, local area network. It's a LAN switch. No, switch is a LAN device. You can extend, you can connect many routers whenever you want and remove it, which is not possible on a serial wire. You don't have any serial switches. Mhm. Fiber. No, it's not fiber. It's not fiber. Nowadays, we don't use much serial. That is why you have this question. Let me show you. So this is the serial wire. You'll have too many pins in this, and whenever you connect two devices on each end, HDLC will run if it is Cisco, as the layer 2 protocol, encapsulation protocol is not Ethernet. It is not Ethernet standard, it is HDLC. If it is non-Cisco, then it is going to be PPP, point-to-point protocol. Now, going back, when you don't have point-to-point serial link, meaning you got Ethernet wire, even though this looks like a point-to-point, this is not considered as a point-to-point because the standard is not point-to-point. This is Ethernet standard. So anytime you will connect a switch and have more devices, so OSPF considers it as network type broadcast. What network type? Broadcast. Which is nothing but LAN. LAN is a broadcast, no? It's a broadcast domain. One LAN is one broadcast domain. When you learn the VLANs, you might have heard this word. One VLAN, one broadcast domain. One VLAN is one virtual LAN. So OSPF will consider this network type as broadcast. Whereas here, OSPF considers it as point to point. You don't need to configure this. You don't need to configure network type as broadcast. Automatically, it considers this. Automatically takes as broadcast as point to point. So here what we see, whenever you have more than two routers in a LAN link, one is already DR, another is already BDR. So two routers are having a role to do. All the other routers have got this name, DR others. Designated router, backup designated router, others. So when I have three routers, among these three, one will be DR. Let's say the priority here is 10 I gave. Here the priority is 5. Here the priority is 0. No, don't put 0. The default is 1. So let us make it as 1. About 0, we'll discuss later. the default, let's have at least on one router. So this router has got 1 as a priority. So the one with the higher router ID, sorry, higher priority becomes DR, and this becomes BDR. And this will be called as DR other. Now between DR and BDR, they will have full relationship. This is also full relationship. Full relationship. What about when I have the fourth router? There is another router which is also having priority 1. This too will have two-way relationship. And this will have with both DR and BDR full relationship. Full. Every other routers will have full adjacency, meaning they will share everything among themselves. Every other router will form full adjacency with the DR and BDR. But between the other routers, they will not share everything. They will have only two-way relationship. They will not share anything, means no updates will be sent between these two routers. Even though they are in same area, they just simply form neighbor, that's all. They don't share anything with the neighbor. Then how can they have identical database? It is through DR. You see, this router shares everything to DR and DR will send it to this guy. Likewise, whatever this other send to DR, DR will send it to this other router. So now they all have full identical database, no doubt. Why it has to go through DR? That is to prevent duplicate updates. Duplicate updates will cause loop. If everyone is talking to everyone, then it is causing loop. To avoid that, everyone is talking to DR only. We'll talk about that in detail later. What I'm trying to say here is, in a WAN link, you have full adjacency, meaning not only forming neighbor, much more than that. In a LAN link, only between everyone with the DR and BDR, they have full adjacency. Whereas with between this DR others, they will only maintain two-way relationship. Two-way relationship is nothing but I know you, you know me, that's all. But we don't share any update. Detail is coming later. Routing updates and topology informations are passed only between the adjacent router. That is what it means. Adjacent, wherever you see adjacent, only to them the routing updates are sent. If you have two-way state only as a relationship, no update will be sent. No topology information will be passed. So they learn through designated router. If you don't understand this, no worries. We are going to see in detail in coming slides. Now, Once the adjacency is formed, you know what is adjacency now? It's not just for neighbor, it's synchronizing with the database. So once the adjacency is formed, you will see LSDBs are synchronized by exchanging the LSIs. LSIs are flooded reliably throughout the area. Very important. Advertisements, link state advertisements. When one router receives advertisement, it won't keep it for itself. It will forward it to the downstream neighbors so that they will also get synchronized. Yep. Next, we have database fully synchronized, which we saw in the previous page. We call it as adjacency. Now on this database, Dijkstra's shortest path first algorithm will run. You see, you got a database. Every router has got a database. What does the database contain? It contains the topology. It contains the map. In that map, each router will locate themselves and then they will form the shortest path to reach remote destinations. That path is nothing but tree. They form a tree, they form a branch, they form the shortest path for every destination. And that shortest path is what considered as the best path. The best path or the shortest path is calculated by comparing the cost. The low cost path is the shortest path. That best path is put into the routing table. I should not say that. The best path is given to the routing table engine called routing information base. Now it is RIB decision whether to use OSPF route or if there is any other protocol like EIGRP giving the same route information with less administrative distance, then RIB is going to follow EIGRP. We discussed this earlier. So see, OSPF will do its job and give it to routing table engine, RIB, routing information base. End of the day, it is the RIB that will decide whether to keep OSPF route or EIGRP route. This is how the SPF algorithm finds the best path. Assume each link has got a cost of 10. 10, 10, 10, 10. Now, if I want to go to this H from X, say all router will have this identical map. Now I am X router. So I will see from here to go to H, 10 plus 10 plus 10. This is 30. if I take this path. If I take this path, 10 plus 10 is 20, plus 10 is 30, 30 plus 10 is 40, 40 plus 10 is 50. 50, if I take this path, 50. I won't take this. I will choose this. Likewise, you, let's say this is you. You position yourself here and say 10 plus 10 plus 10, 30. I'll go this way. Why? Because if I go this way, it is 10 plus 10, 20, 30, 40, 50, too much. So I will not go this way. Likewise, every router will position themselves in this common map called LSDB and find their own path. See, this is going to be more accurate than learning from neighbor. The distance vector protocols like EIGRP and RIP, they learn from neighbor. All right. Now this is an important page. Question is, why are you calling that point-to-point link as that serial link as a WAN link? Why not LAN link? Is it not used inside the office? Why are you then calling it as a WAN link when it is used inside the office? You see, this serial link, even though it is between two routers inside your building, the protocol that they run is a WAN protocol. PPP is one of the WAN protocol. HDLC, which is Cisco's protocol equivalent to PPP. Cisco has designed equivalent to PPP, which is also a WAN protocol. Because the protocol is not Ethernet. Ethernet is what? LAN, right? Ethernet is LAN. Understand that these protocols are not Ethernet. Then what? WAN. That's why it is WAN link. Any other question? Okay, now you go through this for a minute, then we'll discuss on this. You see, one advertisement or many advertisements coming from one neighbor. LSU is collection of LSA coming from neighbor, and a router is receiving it. First, router checks whether the database is empty or any entry is present. If the database have got no info, which means it is empty, there is no info. So whatever comes in, it will add to the database. Because earlier, nothing there inside. Maybe this router just came up, booted. So whatever comes will be received. This is just formed a neighbor, very first update coming. So the database is empty. It accepts it, and then it sends an acknowledgement to the sender saying, I received your updates, thank you. After that, it will flood this information to the other routers. After flooding, you know what will happen. It will run that SPF algorithm. This process will happen. Find its own best path and put the path into the routing table. The end. This is one option. The other option is this router is not just booted. This router is already neighbor When it is receiving update, now it checks the entry. Do I have some entry in my database? Yes, I already have some data entry. I already have some entry. Okay, if I already have entry, the entries, existing entries sequence number and the sequence number coming in the LSU are the same. Are they same? If it is same, why you want to learn again? You already learned the update. So ignore it. If it is different, is the incoming higher? If the incoming sequence number is higher, which means I have a lower outdated one. So what I should do? I should learn what is coming in. So go and add it to the database. Go and add it to the database if the sequence number of the incoming update is higher. What if it is not higher, which means incoming is lower, which means what I have is latest. Because I have the updated one, some sender is sending the outdated one. I'm going to send that sender information saying, hey, my friend, you are giving me something very old. Better take from me. So this router sends to the source what it has got. The end. Whenever it adds something to the database, only then it will send acknowledgement and then it will start flooding to the other neighbors. Here that didn't happen. Why? Because the sender is outdated. So I have to send the LSU to the sender so that the sender will get synchronized with me. The end. This is how every router in the OSPF domain talk each other and make sure that cross check that they are all synchronized. Once they are having identical database, they call themselves as full adjacency. Only they have a fully synchronized database. They will say full state, meaning what? Full adjacency declared. To finalize, to guarantee that they have full adjacency, they have to go through this process. More about this is coming in next chapter. Any question on this page? Now, next. What we see here is, even though I said this is a link state routing protocol, which sends hello packets every 10 seconds, dead time is 40 seconds. There is also one more periodic update. OSPF will send the complete database every 30 minutes, every half an hour. Every half an hour, periodically, updates are sent to the neighbor to make sure everyone knows everything. This point many people don't know. RIP also sends periodic update. That is every 30 seconds. Every 30 seconds, RIP will send the entire routing table, whereas OSPF is only sending link state database in a summarized form called DBD, database description. More detail is coming in next chapter. Every 30 minutes. See, whenever there is a change, they immediately send the change information. That is good. On top of that, to ensure, to guarantee, to make sure everyone is fully synchronized, every 30 minutes, this is also done. Periodic update, sending DBD, database description, which is nothing but LSDB's summary happens. See, link state routing protocol responds quickly to the change by sending triggered update as soon as the change occurs. And it also sends the periodic update every 30 minutes. Important. Next. A two-tier hierarchical network structure is used by OSPF in which the network is divided into areas. This area structure is used to separate LSDB into more manageable size. Yeah, if your database is too big, it is difficult to manage. That's why you have many areas. I told you within an area, you will have identical database. So when you have more areas, you will have more LSDB, not just one. If you have just one, then it will be too big, difficult to manage. So now you have a manageable size DB because you got many areas. So the hierarchical design, two-tier hierarchical network structure is good. Next, adjacencies are built by OSPF routers using hello packets, by OSPF protocol. Over this logical adjacency, LSUs are sent, exchange database information, then they go to full adjacency. Hello is only helping to find a neighbor, but adjacency is formed after exchange of database. Once the database is updated, the Dijkstra's shortest path first algorithm will help to calculate the low-cost path, the best path for each destination. And then the best path is recommended to the routing table. See, what is LSU? LSU contains one or more LSAs. That is what called as LSU, collection of LSAs. So LSAs are sent, and every 30 minutes they get refreshed. Whenever there is a change, LSAs are sent with a new sequence number, which helps the receiving router to update. If it is same sequence number, they ignore. If it is lower sequence number, they don't accept. Instead, they update the sender, which we learned here in this page. All right, that brings us to the end of the first chapter in OSPF. Any question on what you have learned? Are you learning something new? Right. How about Ronaldo? Is it boring or refreshing? You learned these things long back. Fine then.